Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you about linear convolution from the subject of digital signal processing from the unit of discrete time signals and systems in the frequency domain analysis. First of all, what is linear convolution? So linear convolution is basically used to compare any two signals by using the process of convolution. So in the convolution process, we will comparing any two signals. So how we will comparing the two signals, we will see in this topic. Basically, there are two types of signal. Either it will be continuous time signal or it may be discrete time signal. So if we are writing the equation for linear convolution for the discrete time signal, then the equation will be like this: output y of n is equals to convolution of x of n with h of n. It means if we are convolving x of n with h of n, then it will give you the output as y of n. And the equation is summation a equals to minus infinite to infinite x of k into h of n minus k. In this, you can see that we had used the dummy variable k instead of n. And the second signal is minus k. It means it will be folded, then shifted, then we had done the multiplication, and after that we had used the summation. So if we are considering that the convolution, in the convolution there are basically four operations. The first one is folding, then we had done the shifting, then we had done the multiplication of it, and at last we had done its summation. Right. So there are basically four operations which are using in this linear convolution. Now this same equation, if we want to write down for the continuous time signal, then for continuous time signal, instead of the summation, we have to use the integration. So the equation will be like this: y of t equals to x of t is convolved with h of t. As you know that continuous time signal will be representing in terms of t, so it will representing like this. Now if we are using the dummy variable, it will representing as x of tau into h of t minus tau theta. And instead of this summation, we had taken the integration. And we had taken the integration for the entire range from minus infinite to infinite. Now, if we are taking the linear convolution, in the linear convolution, as I told you that there will be four different operations. The first operation is we had done the folding, then we had taken its shifting operation, then we had taken its multiplication, and at last we had done either summation or integration for the two different types of operations, like for two different types of signals, either for continuous or for discrete. For the continuous time signal, we have to use the integration, and for the discrete time signal, we have to take its summation. So basically, in the operation of linear convolution, there will be four different operations. Now, if we are saying that if you want to solve the linear convolution example, then there will be four different methods. The first method is mathematical equation method or mathematical expression method. The second method is graphical method. The third method is tabulation method, and the last method is multiplication method. So we'll solving some example of this convolution by using these four different methods. So the first example is find linear convolution of x of n equals to h of n equals to 1, 2, minus 3, 2. In this, the value of x of n and h of n both will be same. As you can see that the number of terms will be finite, so we can use the tabulation method. In the tabulation method, one side will writing the x of n and one side will writing the h of n. As you know that the value of 1, 2, minus 3, 2 is given to you, then we will write down like this: 1, 2, minus 3, 2. Same way 1, 2, minus 3, 2. Now as you see that in this particular term, arrow is not given to you, so by default we will taking the first term as L. So in the first term we will writing the arrow. Now if you want to solve this example by using the tabulation method, then we had first write the x of n and h of n like this: 1, 2, minus 3, 2, right? Now we will multiply one term with the another term, like 1 will multiply with 1, 2, minus 3, 2. Same way 2 will multiply with 1, 2, minus 3, 2. So the term will be 1 into 1, 1, 1 into 2, 2, 1 into minus 3, 3, minus 3. 1 into 2, 2. Same way 2 into 1 means 2, 2 into 2 means 4, 2 into minus 3 means minus 6 and 2 into 2 means 4. Same way we're finding for all the other terms. Now we have to draw this line. In this line, you have to keep in mind that in the first term there will be only one term. Then in the second line there should be 2 terms, then 3 terms, 4 terms likewise, and then it will be in the decreasing order. Now in one line, if we'll add in these terms, then answer of it will give you the linear convolution output. So what will be the output? Output will be representing as y of n and answer of it equals to, in the first term only one term is there, 1. So we'll writing directly 1. And then in the second term 2 plus 2 means its answer is 4. Then the next term is minus 3 plus 4 plus minus 3. So the answer will be minus 2. Next term is 2 minus 6 plus 2. So answer will be minus 8. Same way we'll finding 4 plus 9 plus 4 means answer equals to 17, and the next row will be minus 6 means minus 12, and the last term will be 4. Now in the answer, why we'll writing the arrow? So as you can see that the arrow will be given in the x of n and h of n on the first position. So in the output also there will be arrow below the first position, because 0 plus 0 will give you the 0. So the first term will consider as n equals to 0. Now the next example is find linear convolution of x of n equals to 2 minus 3 4. In this arrow is given below the minus 3. Same way h of n is given to like minus 1 2 4. In this arrow is given below the minus 1. So if we are finding the range of x, then its value will be in between. Arrow is given to you, it means its value is n equals to 0, right? So before 0 the value will be minus 1, and after 0 its value equals to 1. So the range of x will be in between minus 1 to 1. Same way if we are finding for the range of h, then its value will be, arrow is given below the first term, so it will starting with 0 and it will end up to 0, 1 and 2. So it will end up to 2. So the range of h will be 0 to 2. Now if you want to find out the answers range of n, then we have to just add in this two ranges. Minus 1 plus 0 means minus 1 and 1 plus 2 means 3. So the output range will be in between minus 1 to 3. Now we have to solve this example by using the tabulation method. So we are writing x of n one side and h of n on the another side. So we are writing like this: 2 minus 8 4, minus 1 2 and 4. Now we will multiplying all the terms with another one, then we will drawing this line, and in this line we will adding the terms. So the answer will be like this: minus 2, 4 plus 3 means 7, 8 minus 6 minus 4 means minus 2, minus 12 plus 18 means minus 4, and the last term will be 16. Now as you see that the range of n for the answer will be minus 1 to 3. So the answer will starting from minus 1, so you can imagine that after minus 1 the next term will be n equals to 0. So on the second term, below the second term will join the arrow. So this will be considered as the final answer of this linear convolution. Now the next example is find the linear convolution of x of n equals to a raised to n u of n and h of n equals to b raised to n u of n. Now you can see that in this example u of n is given to you. Now what is the value of u of n? U of n will be ranges from 0 to infinite, its value equals to 1, right? So we can't take infinite times 1, so we can't use the tabulation or multiplication method for this particular example. So in example, if u of n term will be given to you, then you have to use either mathematical equation method or you have to use the graphical method. It means we have to draw graph for each and every term. Starting with this, x of n is given to as a raised to n u of n and h of n equals to b raised to n u of n. Now as you know that equation of linear convolution is y of n equals to x of n convolved with h of n. So equation of it equals to summation k equals to minus infinite to infinite x of k h of n minus k. In this we have to take the value of x of k and h of n minus k, right? So in this equation, instead of n, we will take in the value of k. So this term will convert in terms of x of k equals to a raised to k u of k. And the second term will convert in terms of, instead of n, we will take in n minus k. So the value will be h of n minus k equals to b raised to n minus k into u of n minus k. Now from these two terms, we will draw the graph. Now you can see that u of k equals to, it will be similar as u of n, right? So what is u of n? Its value equals to 1 or 0 to infinite. So if we are taking u of k like this, then what will be the value of u of minus k? So if we are finding the value of u of minus k, its value will be folded from this sequence. So its range will be from minus infinite to 0, its value equals to 1. So if we are finding the shifting operation of u of minus k, then it will give you the answer as u of n minus k. So it will be shifted toward n. So it will be shifted up to n. So the value of it will be 1 or minus infinite to n. Now if we are putting these two values in this equation, so the next step will be summation k equals to minus infinite to infinite, a raised to k, u of k, b raised to n minus k, u of n minus k. Now you can see that if we multiply these two terms, then you can see that 0 into any term will become equals to 0 and any term into 0 will become equals to 0. These two terms will be only in the range between 0 to n. So up to 0 to n only, this 2 has the value equals to 1. So the range will convert in the form of summation k equals to 0 to n, and for this range the value of u of k and u of n minus k will be 1. So the term will becomes like this: summation k equals to 0 to n, a raised to k into 1, b raised to n minus k into 1. Now if we simplify this last step, so the next step will be y of n equals to summation k equals to 0 to n, a raised to k into b raised to n minus k. Now as you see that this summation is of k, so the value of b raised to n will be considered as constant, so it will be outside of this summation. So first of all, it's simplifying this term as b raised to n minus k equals to b raised to n into b raised to minus k. So after taking the constant term outside of the summation, the next step will be b raised to n summation k equals to 0 to n, a raised to k, b raised to minus k. It will convert in terms of a raised to n, right? So here the summation is of k, so we write it a raised to k form. So the term will be like this: a by b raised to k, because b raised to minus k means b raised to minus 1 raised to k, and b raised to minus 1 means 1 by b. So the term will be a upon b raised to k. Now if we taking the summation rule, then this, as you know that the summation n equals to n1 to n to a raised to n, then the term will be a raised to n1 minus a raised to n2 plus 1 upon 1 minus a. Now comparing this equation with this, then the value of capital A equals to a by b, the value of n1 equals to 0, and the value of n2 equals to small n. So if we are putting these three values in this equation, so the next term will be y of n equals to b raised to n, a by b raised to 0 minus a by b raised to n plus 1 upon 1 minus a by b. Now if I am simplifying this, then any term raised to 0 means 1, and after simplification of this, its answer equals to b raised to n plus 1 minus a raised to n plus 1 upon b minus a. So this is the final answer of the linear convolution of any two signals x of n with h of n. In this we had used the unit step signal. So if the unit step signal is given to you, then you have to solve this particular example by using the mathematical expression method or with the help of graphical method. Now the next topic is properties of linear convolution. There are basically three properties of the linear convolution. The first property is commutative. What is commutative property? If we convolve x of n with h of n, or if we convolve h of n with x of n, both will be same. So x of n is convolved with h of n equals to h of n convolved with x of n. This will be considered as commutative property. Now the next property is associative property. If we are taking three different signals and then convolving these three things, then if the order will change, then there will be no change in the output of this convolution. So it will consider as associative property. So in this we are taking x of n is convolved with h of n and z of n. It means we will find in first of all the output of h of n convolved with z of n, and it will be convolved with x of n, or if we'll first of all finding the value of x of n convolved with h of n, and answer of this will be convolved with z of n, both answer will be same. And the last property is distributive property. The distributive property will be representing as x of n is convolved with h of n plus z of n is equals to x of n convolved with h of n plus x of n convolved with z of n. So it means if we're finding, first of all, if we're finding the value of h of n plus z of n, and answer of it will be convolved with x of n, it will be same as x of n is individually convolved with this two signal, and answer of it will be get added, then the answer will be remain same. Thank you so much.